Good morning everyone. I am Renu Sharma, Assistant Professor, Ajay Kumar Garg Engineering College. Today I am going to start with the next part of the topic, that is error detection and correction codes, that is part 3 for the subject, that is data communication network AEC 063. So, these are the contents of my lecture. First I will discuss about what is framing, then I will discuss flow and error control, then different protocols. So, I will begin with what is framing. So, previously we have seen that whatever work we will do, it is in the form of layers, layered tasks are there. If I want to transmit a parcel from one place to another, then it will be first handed over to a courier service, means at the post office, then from the post office it will be given to a person, then it will be transmitted from one place to another, then the reverse action will take place at the receiver side. So, which means that it is not a one person work, it is in the form of different layers. So, different layers are it will work on two models. First one is the OSI model and another is the TCP IP model, that is transmission control protocol, internet protocol model. Now, this data link layer, it is a part of TCP IP model, or you can say the OSI model. OSI model is nothing, it is a 7 layer architecture. That's first layer is presentation layer, data link layer, then network layer, transport layer, session, presentation, followed by the application layer. So, these are the 7 layers of the OSI model. So, the data link layer needs to pack the bits into frames, so that each frame is distinguishable from another. So, in frames, what do you mean by frame? Whenever your original message data is headed by a header and it is ended by a trail bits, this is known as the header, this is known as trail bits. So, whenever this form of packet is formed, it is known as the frame, means you have formed a particular frame in which it is headed by the header. Header will consist of what kind of information? The header will consist, it will consist the synchronization information, it will consist the source address, the destination address, the logical address. So, this is the information that the header will be carrying, and it is followed by the original message bit, then it is followed by the trail bits. Now, trail bits will going to signify that yes, the frame has been ended over here. So, this is how the data link layer frame will work. One of the best example is the postal system practices. It is a kind of framing technique basically. The simple act of inserting a letter into a envelope separates one piece of information from another piece of information. The envelope will serves as the delimiter basically. So, this is all about the framing, you can say. So, it is in the form of layered task is there. Now, next is the frame in a character oriented protocol. So, what is a character oriented protocol? Character oriented protocol means you are inserting the bits, you are inserting the characters into the particular frame. So, this is the flag which will going to show you that yes, the particular frame has started, the information in the frame has started, then it is followed by the header. It will consist of the source header, the destination address, the logical address. So, this type of information will be presented in this header. Then the data from the upper layer, variable number of characters will be there, it is not in the form of 1 and zeros, it is in the form of the characters. Then it is followed by the trail bits and the flag. So, that flag after the trail bits will going to signify that the particular frame has been ended over here. So, this is how the character oriented protocol will looks like. Next is the byte stuffing and unstuffing. What is byte stuffing? First thing is that 8 bits is equals to 1 byte, 8 bits is equals to 1 byte of information. So, data from the upper layer will be received in here, which is the flag followed by this ESC. Then you have to stuff the byte. So, byte will be stuffed at the sender side when the frame will be formed, means you can see that the frame sent, this is the frame that you have to send. This consists of this flag followed by the header information, then ESC will be there, flag, again ESC will be there and the trail bits followed by the flag. So, you can see that the stuffing will be there and this stuffing is nothing, it is in the byte information. Then this information will be received, that is nothing, it is the frame that has received frame information followed by the header. Then this is ESC and flag, then again ESC and trail bits will be used over here. So, this is nothing, it is the byte. Unstuffing will be there on the unstuffed, means the data is again received back into its original form. So, this is the byte stuffing and unstuffing will be there. Now, next is the frame in a bit oriented protocol. So, previously we have seen the character oriented protocol, where the data is in the form of character, bits will be there, it is not in the form of bits, but you can see that whatever data is presented over here, it is in the form of bits only, it is not in the form of character. So, this is the flag, this is the header, trailer, and then the data from the upper layer, and it is of the variable number of bits will be there. So, a frame in a bit oriented protocol will be used over here. Now, next is the bit stuffing and unstuffing. So, you can see that in this situation we are not stuffing the bytes, means 8 bits will not be inserted, we are going to insert only 1 bit and it is denoted by this color. You can see that in this stream of data which is of more than 10 bits, you are inserting only extra 2 bits will be inserted. Same bits will be unstuffed at the data which has to be delivered to the lower layer. So, this is the bit stuffing and unstuffing part is there. Now, next after studying this bit stuffing, unstuffing, byte, bit oriented protocol, character oriented protocol, we will going to see next the flow and error control. The most important responsibilities of any data link layer is the flow control and error control. What is flow control? If I am transmitting 10 bits of data, then same 10 bits of data at the appropriate time is to be received at the receiver side. This means that the work of synchronization is very important here. In that situation, if the proper synchronization is not maintained between the transmitter and receiver, then this transmission and reception will not take place appropriately. Collectively, these functions are known as data link control. Next is after the flow control, this error control is also there. What is error control? This consists of two operations, error checking and error correction. In case of error checking, you have to check that whether the error has occurred or not, and in case of the error correction, you have to correct that particular error. If the error has occurred and you cannot means you cannot remove that particular error, you have to remove that particular error. So, this is the function of this error control. Now, both the operations of flow control and error control has to take place at the data link layer. Next, we will move to protocols. What are protocols? Protocols are nothing, it is a set of rules that has to be agreed by both the transmitter and receiver. It has to be agreed that yes, that particular transmitter will going to transmit in that particular language, let us say in French language, and the receiver will going to receive that information in French language also. So, this is the set of rules that has to be decided by both transmitter and receiver. The data link layer can combine framing, flow control and error control to achieve the delivery of data from one node to another. So, what are the operations that has to be done at the data link layer? These operations are flow control, then error control and then framing. So, these three operations has to be done at the transmitter side, at the data link layer, flow control, error control and the framing information. The protocols are normally implemented in software by using one of the common programming languages To make our discussion language free, we have written a pseudo code, a version of each protocol that concentrates mostly on the procedure instead of delivery of the details of the language over here. So, what we have seen that instead of using technically, if we are considering any kind of language, it is not much more easy to understand. If I say that I am going to explain in French language, maybe you are not going to understand it. So, a very common basic example we are considering, that a pseudo code will be generated, that is the pseudo noise or the pseudo code, that is randomly generated code, that is not language specific, it is only done or agreed by the transmitter and the receiver, means any user can use this pseudo code for transmission and reception purpose. Now, different types of protocols are available. It is dependent on whether we are considering the noiseless channel or we are considering the noisy channel. So, in case of this noiseless channel, there are two types of protocols are available. First one is the simplest protocol, second is the stop and wait protocol. In case of this noisy channel, there are another three types of protocols are available. Stop and wait ARQ, automatic repeat request ARQ, full form is automatic repeat request. This is the full form of ARQ. So, stop and wait ARQ I will take, go back and ARQ I will take, or selective repeat ARQ I will take. So, this is for the noisy channel and this is for the noiseless channel I will take. So, this is the protocols, different types of protocol I am considering, simplest type, stop and wait, and in case of this noisy channel you can see this stop and wait ARQ, go back and ARQ and selective repeat ARQ. We will see each one by one in detail. So, this is the design of the simplest protocol with no flow or error control. Means in this whenever this code is used at the data link layer, it does not consist any kind of flow or error control. It will only going to transmit the data which maintains the framing which consists of the framing part. Now, this is at the sender side, this is at the receiver side. Now, this network will generate these are the different layers, these are the three layers of the OSI model, that is the physical layer, first layer, data link layer and the network layer. From the network layer, the data will be transmitted to this data link layer, it will be formed in the form of frame at the physical layer. Now, these data frames will be transmitted from the sender side to the receiver side in the form of these data frames. Then an event has occurred over here, you can see in this diagram, request from the network layer, it will going to request from the network layer, repeat forever algorithm for the sender side. So, different algorithm will be set up at the sender side, that whether you have to repeat or you have to request for the particular packet or not. Then at the receiver side, it will again have a notification from the physical layer, the algorithm for the receiver side, and you can see that how the data will flow. It will be received from this receiver, it will be given to this data link layer and then it will be delivered to this network layer. So, you can see that for the OSI model I have taken I have shown only three layers, that is physical layer, data link layer followed by the network layer, and this these are the algorithms that are being used at the sender side and at the receiver side. This is for the repeat forever, means you are going to repeat that whether it has to transmit the data or not. It will only work on the one of the three characters of it, that is the framing part. It will going to form the frame for the transmission purpose, it will not going to be a part of this flow and error control. Now, next is stop and wait protocol. Now, this stop and wait protocol you can see as some changes there. Whenever you are going to transmit the data, get the data from the network layer, it will be given to this data link layer, then it will going to transmit the data, send the frame and the frame will be transmitted to the receiver side. Now, this sender will have to wait for the acknowledgement purpose, it has to wait like it has to wait over here that whether this acknowledgement frame has received at the sender side or not. If it is not received, then it has to wait for particular frame over here. So, this is the data will be sent from this sender, it will acknowledged at the sender side, then the next frame will be transmitted. So, this means you have to first transmit the data, you have to stop and then wait for the acknowledgement frame to be received at the receiver side, at the sender side. Then it will be works on the principle of this algorithm that has been set up at the sender side and at the receiver side. This is the event that has been occurred, notification from the physical layer, and this event has occurred at the notification layer at the receiver side. So, this is the design of stop and wait protocol. Now, next is the design of stop and wait ARQ protocol. Now, this is a part of noisy channel. Till now, we have discussed two types of protocol, which are the part of noiseless channel, simplest type of protocol, and next is the stop and wait protocol. Now, in this diagram, which is stop and wait ARQ protocol, this is a part of noisy channel. Now, you can see that this is the next frame to send. You can see that a frame has been generated over here and a frame will be generated over here. This is the next frame that you have to send and this is the next frame that you have to receive, that has to match together. The data will be transmitted or generated at the network layer, get the data at the network layer, it is being received at the data link layer, then it will be sent at the physical layer and then it will be given at the receiver side. Now, in the back receiver side, it will be transmitted and this is the acknowledgement frame. It has to be received at the transmitter side. The time till when this frame is not received, it has to wait till that time, that frame has to receive. You can see a timer will be used in this algorithm, which will going to decide that it will going to repeat after that particular time, because the name of ARQ is automatic repeat request, at it will automatically going to repeat after a particular point of time. So, this is the design of the stop and wait ARQ protocol. Now, next is the design of go back and ARQ protocol. You can see that this is the first outstanding frame that has to be transmitted, sender frame. This is the next frame to send, means up to this point this is the outstanding frame, this has already sent. Now, after this these orange blocks will be sent, then these frames has to be sent in the next part. So, this is the sender side, the data has to be sent in the form of frame. This is the sequence number. Every frame will have their own sequence number. Let us say I want to transmit 10 bits of data and I have divided into n 5 number of frames. So, each frame will consist of 2 bits of data. So, each frame will be numbered, means sequence number will be added to each frame. Now, this data will be transmitted to the receiver side, it will be transmitted, it will be received over here, this is sent to the receiver. Then you can see that design of the go back and protocol will be shown over here. This is the algorithm for the sender side and this is the algorithm for the receiver side. This is repeat forever notification from the physical layer and this is the notification from the other layer will be shown over here. So, request from the network layer is shown over here and this is the request. In this case you can also see that whenever the automatic repeat request operation is there, then a timer will be used. This timer will going to repeat after a particular point of time. Another point that you have to note, that the size of this receiving frame is equal to 1. You can see over here the size of this receiving, that is Rn will always be equal to 1 in this case, that is go back and ARQ. But in this case it is user specific, you can select any size of the transmitter frame. Here we have used 4 bits of data that has to be transmitted or that has already been transmitted and waiting for the acknowledgement to be received. So, this is the go back and ARQ. So, why we are considering go back, and n means n is the number of bits or number of frames that you are transmitting in one go. If it is not received at the receiver side, if the acknowledgement of these particular n number of blocks is not received, then you have to wait for that particular point of time till the timer is there. Then after the timer is out, then you have to either again send that particular data, or you have to wait for the acknowledgement for the particular frame that you have to receive. Now, this is about the go back and ARQ. So, in this lecture what we have seen, let me summarize. In this lecture we have seen different types of protocols. Before that we have seen flow and error control. So, this lecture is all about the data link layer, what are the operations are performed at the data link layer. At the data link layer, this is the second layer of the OSI model. In this layer we have to generate the frames. Framing is the main operation which is performed at the data link layer, means you have to add the header and you have to add the trailer bits at the before and after the message. Like this is the message, you have to add the header bits, you have to add the trail bits. So, this is how the frame will be formed. Now, this framing is one of the operation which is performed at the data link layer. Another operation that is performed at the data link layer is known as flow and error control. Flow control means the synchronization has to be maintained between the transmitter and receiver. At what time I am going to transmit the data, it has to be received at appropriate time at the receiver side. Error control means you have to receive at the receiver side, you have to check the redundant bits. If error has occurred, then you have to either discard that particular message or you have to correct the message bits. So, this operation will be performed by CRC coding, by convolution coding, by cyclic code, any type of code you can consider. Next, we have seen protocols, different types of protocols that are used for the purpose of transmission. Two types of channels are there. First one is the noisy channel, another one is the noiseless channel. In case of this noisy channel, there are two types of protocols are there. First one is the simplest protocol, in which you do not have to wait for the acknowledgement, you just have to send the frames. And in the second type of coding, you have to wait for the acknowledgement, stop and wait protocol. Now, when we are moving towards the noiseless channels, then automatic repeat request operations are there in all the three cases, that is go back and stop and wait protocol, and another one is the simplest kind of protocol, ARQ protocol. So, this in all the three cases you have to use a timer for the algorithm at the transmitter side, like this is the timer, like it has to wait for that particular time that you have set for the acknowledgement. If the acknowledgement has not received and that particular time, it has to repeat the particular transmission once again, or you have to check that whether the error has occurred or not. So, this is the diagram for this go back n, and the main point that you have to note in go back n, the size of the sending window and the receiving window. In case of the sending window, the size of the particular frame is user specific, like I have taken 4 over here, and in the receiving window the size of this will be denoted by n 1. So, the size of the receiving window will be given as 1. Now, every frame will have their own sequence and the acknowledgement is shown like this, and this is the timer. So, this is about the protocols that we have to use in the communication part. These are the references that I have used, and you can also use for this purpose. Thank you.